So the this is a horrible way to have a math lesson, but you have to understand down to your bones that mathematics has some real manifestations in the other academic subjects to where it's so obvious. It's like two crystals that have grown together. It's so obvious that math has a perfect application to those areas because not only of how well it works, but because they bear such strong properties to each other. Stuff. Math is married to the law. Okay, math is married to computer science. In fact, the first programming languages started off as mathematical information, COBOL and Fortran and stuff. Classes in computer science are literally made up, are the same material as, just strings of mathematical information stuff. Um, Math is married to physics. Math is married to technology. It's not just computer science, but technology in general and stuff. Um, Math is married to philosophy and stuff. Philosophical information is perfectly expressed in mathematical terms and stuff. Um, we have logical symbols for everything. And uh, hmm, I mean, if you want to distinguish statistics for whatever reason, math is definitely married to statistics. Um, Math is married to science and stuff. Science kind of leaves itself open to applications of reason and stuff, which is the basis for philosophy. It's part of a foundation and stuff. Um, Theoretics is a branch of philosophy that is rather underdeveloped and stuff, but I'm interested in it, and I like to write in it and stuff. And it is definitely married to mathematics and stuff, in the sense that it's so obvious that they're variations of each other. Now, which gives a rise to a question like, are there alternatives and stuff? Like when you omit all of this rational thinking and analysis and calculation and stuff, like, is there something else? Sure, people dream, people feel, you know, um, and there's many ways to to, in a sense, realize that. Realize here in the sense of, it's actually coming to fruition. So, not like in the sense of realizing in one's mind, you know. Like there's even areas of philosophy that the tools of mathematics and science cannot really touch without a lot of exertion and stuff. Um, it becomes much more natural and convenient to just look at philosophically. You know, everything from the topic of deities, uh, political decision making, um, I guess, cultural design, morality and stuff.
Okay, so that was a recording I made. Um, these are basically the areas where mathematics is most effective and powerful, and where each of these subjects bears traits that are mathematical in them, and mathematics bears the traits in them. It's like they're a real manifestation of mathematics, you know, like a crystal made of two that were grown from two separate crystals together, but it all makes sense. You know, it's like all a coherent crystal. There's you know, in this crystal there's no discontinuities. So there's no air bubbles or anything like that. So yeah, so physics, of course. I mean, basically the mathematical explanation of, you know, movement of forces and energy, the motion of bodies, the quantum level, classical level, blah, blah, blah. It's extremely mathematical. Law and stuff. Law draws heavily on philosophy and logic. Oh my God, that's covered heavily in math. Economics, philosophy, science. Science is a very rational discipline. Okay, requires a lot of reasoning, testing assumptions. In math, I can think of off the top of my head, I can think of two ways we test assumptions. By checksumming, meaning we just check the facts to see if something's right. Check, you know, or perform some simple test, or we set up a statistical test, like hypothesis testing. You know, statistics, if it must be distinguished from math. It's of course it's a form of applied math, but I don't know. You know, like focusing heavily on statistics, you kind of lose what math really is. You know, computer science. Again, the first programming languages, COBOL and Fortran, were made mathematically and stuff. Computer programs work a lot like mathematical language. Technology, you know, basically heavily dependent on the statistical calculations of how things work. You know, analyzing things such as tension, temperature propagation, and stuff, trajectories, electrical calculations, logistical planning, geometry, you know, kinematics, applied quantum theory, atomic physics, stuff like that. You know, so yeah, so off the top of my head, these are the 8 areas where mathematics best works and stuff. They're basically flawless. So I mean, now is the law perfect? Hell no. And I have a whole video on that. But the law is a very sensitive area, and there are laws about that stipulate how to talk about the law and stuff. Meaning, you better be telling the truth. So I'm very cautious to make sure that I'm being factual and just talking about things, and not just stating my opinion. I'm just, you know, explaining the facts that I know. So conclusions in that rational, respectful way of just being honest. Okay, but yeah, there.